Look at the room you are sitting in. Look at the walls. Look at the screen. You feel like you are the inevitable product of Earth's history. You feel like humanity is the endpoint of a linear process. We built the roads, we split the atom, we touched the moon, we defined the planet. But ask yourself a question that sounds impossible until you examine the raw data. How do you know you are the first? Earth is 4.5 billion years old. That number is too vast for the human mind to process. To grasp it, let us compress the history of our planet into a single 24-hour day. Earth forms at midnight. Life begins around 4 a.m. But complex life, animals, they do not appear until late in the evening. Dinosaurs show up around 10:45 p.m. They exist for almost an hour. And us? Homo sapiens? We emerge at 11:59 p.m. and 58 seconds. All of recorded human history, every empire, every war, every invention, fits into the final fraction of the very last second. So here is the scientific problem. What happened in the morning? What happened in the afternoon? What happened during those long, quiet hours before we arrived? We assume the Earth was empty. We assume the system was dormant. But that is an assumption, not a data point. Science tells us that complex biology has existed on this planet for at least 400 million years. An industrial civilization like ours has existed for only 300 years. Do the math. You could fit an industrial cycle into the geological record, not once, not twice, but thousands of times over. And the timeline would barely register it. This is the core of the Silurian hypothesis, a paper published by National Aeronautics and Space Administration scientists. It poses a disturbing question. If an advanced biosphere existed 50 million years ago, would the planet retain the evidence? Or is Earth a self-correcting system designed to wipe the hard drive? This is not a story about history. This is a story about mechanism. We need to understand if the planet we live on is a vault that preserves our secrets, or a processor that systematically overwrites them. You struggle to accept this. Your cognitive bias says, if there were others, we would see the structures. We would find a buried skyscraper, a machine, a microchip, encased in rock. We find dinosaur bones. So why would we not find the ruins of a pre-human empire? This is a scaling error. You are judging the durability of the past by the durability of the present. You look at a pyramid and think, stone lasts forever. You look at a highway and think concrete is permanent. But you are thinking in human years. In geological time, stone is a liquid. In geological time, concrete is just temporary grit waiting to scatter. We need to recalibrate your perception of time. The Earth is not a static archive. It is a dynamic, active recycling plant. It does not preserve. It processes. Consider the mechanism of the surface. The crust is not solid. It is a conveyor belt. Tectonic plates are constantly shifting, colliding, and sliding under one another. This process is called subduction. The ocean floor, where most sediment and debris collect, is eventually dragged down into the hot mantle and melted. It is recycled into magma. The Earth literally devours its own surface. Geologists estimate that most of the ocean floor is younger than 180 million years. If a civilization existed 200 million years ago and built their infrastructure on the coastlines, those structures are not just buried. They are liquefied. They are gone. The data has been melted down to its atomic components. And the continents? They are scoured by wind rain and ice. Every mountain you see is slowly dissolving into the ocean. The Appalachian Mountains used to be as tall as the Himalayas. Where did that mass go? It became sand. It became mud. It became nothing. So when you ask where are the ruins, you are looking for a structure that has been burned, ground into powder, washed into the sea, compressed into rock, and then melted in the Earth's core. That is the scale of data erasure we are dealing with. To truly understand the efficiency of this erasure, we have to look at ourselves. We have to run a simulation of our own disappearance. Let us play a game. Imagine humanity vanishes tomorrow. No war, just a sudden cessation of maintenance. The pumps stop. The painting stops. What happens to our eternal infrastructure? Day 1. Power fails. Year 1. The biological reclamation begins. Weeds crack the pavement. Water seeps into the basements of skyscrapers. In winter, that water freezes and expands, shattering the concrete foundations from the inside. Year 50. The roofs collapse. Without roofs, the interiors are exposed to the elements. Wood rots. Drywall dissolves into paste. Year 200. The skyscrapers fall. The steel skeletons inside the concrete rust. Rust expands, blowing out the support columns. The skylines of New York, Shanghai, and Dubai tumble down into mounds of rubble. Year 1000. The forests have returned. The debris is covered in soil. The Statue of Liberty has fallen and is dissolving in the corrosive salt water. Now, accelerate the simulation. 10,000 years. The pyramids of Giza are worn down to nubs by sandstorms. 100,000 years. A new glacial cycle begins. Ice sheets miles high roll down from the poles. They act like planetary bulldozers scraping the land down to the bedrock. They push the remains of our cities into the ocean trenches. They grind our legacy into a fine powder called glacial flour. 1 million years. A blink of an eye in geological time. What is left? The glass has turned back into sand. The paper has turned into dust. The wood has turned into dirt. The iron has turned into red rust stains in the sedimentary layer. If an observer lands on Earth in 2 million years, they will not find a single road. They will not find a single building. They will not find a single book. Everything you see around you right now, this screen, your chair, the walls of your house, is destined to become sediment. We are not building a monument. We are creating a thin layer of geological noise. But wait, you think, what about stainless steel? What about gold? What about our massive machines? This brings us to the chemistry of the system. Thermodynamics has a rule: nature seeks equilibrium. Nature hates high energy states. Refined metal is a high energy state. Iron ore is stable. Steel is unstable. Steel is iron that has been forced into a stressed configuration by removing oxygen. It desperately wants to return to being ore. It wants to oxidize. And given enough time, thermodynamics always wins. Every car, every bridge, every beam is slowly burning in cold motion, reacting with the oxygen in the air to return to the earth. Gold is stable, yes. Gold does not rust. But gold is soft. And gold is rare. If a future observer finds a gold ring, will the shape survive the crushing pressure of the strata? Or will it be flattened into a shapeless nugget? And even if the shape survives, does a gold nugget prove an industrial civilization? Or just a geological anomaly? Then consider the pressure. Sediment accumulates. Layer upon layer of mud and sand piles up over millions of years. The weight becomes immense. Heat and pressure transform the landscape. Our landfills, our cities, our bodies, they are cooked. They undergo diagenesis. They are lithified, turned into stone. Imagine a laptop. Plastic casing, silicon chips, lithium battery. Bury it in mud. Apply 10 tons of pressure per square inch. Heat it to 200 degrees Celsius. Wait 5 million years. What is the output? You do not have a laptop. You have a smear of black carbon, a trace of heavy metals, and a slight chemical variance in the shale. You are looking for technology. But the Earth converts technology into chemistry. This is the key realization. If we want to find the civilization before us, we have to stop looking for shapes and start looking for elements. Okay, you argue reaching for one last variable to save us. But our bones. We are 8 billion distinct biological units. Surely our skeletons will remain. We found the dinosaurs. Let us correct this assumption. Fossilization is not the standard operating procedure of the planet. Fossilization is a statistical glitch, a rare error in the decomposition process. For a bone to become a fossil, it must be buried immediately in oxygen-free mud. It must not be scavenged. It must not be scattered. It must be mineralized by groundwater. And then it must survive millions of years of tectonic pressure without being shattered. and then it must be pushed back up to the surface exactly when an observer is present to find it. Consider the Tyrannosaurus rex, one of the largest, most robust animals in history. Scientists estimate that roughly 2.5 billion T-Rexes lived and died over their existence. Do you know how many complete skeletons we have recovered? About 30 out of 2.5 billion. That is a preservation rate of virtually zero. Entire species of dinosaurs are known from a single tooth. Entire ecosystems have vanished without leaving a data trace. Now apply that to humans. We live on dry land, not in swamps. We cremate our dead or bury them in shallow soil where oxygen destroys biological matter. If humanity disappeared today, statistical modeling suggests that in 100 million years, there might not be a single recognizable human fossil left on the entire planet. So let us pause and review the dataset we have assembled in this first act. We have realized that deep time is vast enough to hide thousands of industrial cycles. We have realized that erosion and tectonics are actively grinding the surface, destroying physical evidence. We have realized that human structures are chemically unstable and will dissolve in a blink of geological time. And we have realized that fossils are a statistical anomaly, not a reliable record. The conclusion is mathematical. If a civilization arose 50 million years ago, built cities and then vanished, there would be nothing left for us to see on the surface. The silence of the geological record is not proof of absence. It is proof of the system's efficiency at cleaning up. But notice I said on the surface, because while the physical objects disappear, the processes of a civilization leave scars, not in the shape of the land, but in the chemistry of the atmosphere, in the atomic balance of the planet. We cannot find their buildings, but maybe we can find their exhaust. Because if there is one thing an industrial system does, it burns resources. And burning resources changes the isotopic ratio of the sky. Let us calibrate our instruments. Let us look for the ghosts in the atoms. You might think that even if stone and steel fail, our synthetics will endure. We are told that plastic is eternal. You imagine a layer of polyethylene bottles and nylon gears surviving in the rock, like technological diamonds. This is a miscalculation of biological adaptability. Nature does not tolerate unused energy. Plastic is at its core a chain of hydrocarbons' potential energy waiting to be processed. For a brief moment in history, it was immune to decay because it was novel. But biology adapts faster than geology. In 2016, researchers identified a bacterium Ideonella sakaiensis. It evolved in a waste facility. It possesses enzymes specifically designed to break the molecular bonds of polyethylene terephthalate plastic and digest it. It took nature less than 80 years to engineer a solution to consume our indestructible invention. Extrapolate this over 1 million years. Bacteria and fungi will evolve to metabolize our landfills. They will strip the plastic down to its elemental components. The result will not be a recognizable shape. It will be a thin, compressed layer of carbon sludge mixed into the sedimentary matrix. Future analysis will not find a plastic fork. They will find a slightly oily layer of dirt. The structure is lost. Only the chemistry remains. So even our waste, our most abundant output, is not permanent. It is just feedstock for the next epoch of microbial life. Now, let us widen the scope to the planetary stage. You trust the map. You know where New York is relative to London. You assume that if a civilization establishes a location, that location remains valid. But the crust is a fluid system moving in slow motion. Continental drift shift the plates at a rate of roughly 2 to 5 centimeters a year. That appears negligible to a human observer, but we are discussing deep time. Over 50 million years, that movement adds up to thousands of kilometers. Africa rifts apart. Antarctica migrates north. New mountain ranges uplift, crushing the previous surface. Old mountain ranges are eroded down to flat plains. If a civilization established a megacity on the coast of California 50 million years ago, that city would not just be ruined. It would be geographically relocated, buried under miles of new sediment, or pushed up into a cliff face and eroded into the sea. The very coordinates of existence are erased. The map ceases to be a reference point. An observer in the future is not just looking for a specific data point, they are looking for a data point that has been scattered across a chaotic moving grid. If erosion is the sandpaper subduction, is the incinerator. This is the most efficient data wiping mechanism on the planet. Civilizations tend to cluster on coastlines. We build ports, power plants, and trade hubs near the ocean. But the ocean floor is the most temporary surface on Earth. New crust is created at mid-ocean ridges and spreads outward. Eventually it hits a continental plate and dives underneath it, plunging into the mantle. This is why the oldest ocean floor on Earth is only about 180 million years old. Any ocean floor older than that has been recycled. It has been melted down. Consider the implications. If a species built a global maritime empire 200 million years ago, their ports, their ships, their coastal infrastructure are not hiding under the mud. They have been fed into the planetary core. They have been returned to a molten state. The hard drive was not just formatted, it was melted. The Earth is constantly refreshing its surface. It deletes the old to make room for the new, and we are currently living on the surface that is scheduled for deletion. So what is the final output of all these processes? Erosion oxidation, biological digestion, tectonic recycling. The output is a layer of sediment. If humanity lasts for another 1,000 years, and then vanishes the entire sum of our existence, our wars, our art, our internet servers will be compressed into a layer of rock, a few centimeters thick. Geologists call this an event horizon in the strata. To a future observer, we will not look like a civilization. We will look like a strange, sudden fluctuation in the background noise of the planet. A brief spike in nitrogen, a sudden deposit of heavy metals, a strange dusting of radioactive isotopes. We will look like a natural disaster. When we look at the geological record of the past, we see these thin, odd layers everywhere. We see the KPG boundary, a thin line of iridium that marks the end of the dinosaurs. We assume it was an asteroid, but looking at that thin line, we realize how much information has been lost. That line represents millions of years of life, compressed into dust. We are not carving our names into the bedrock. We are depositing a thin chemical shadow. This brings us to the pivot point. We have established that physical evidence is fragile. We have established that the Earth is an active eraser. So if we cannot trust our eyes to find ruins, how do we detect the others? In 2018, Gavin Schmidt, a climatologist at National Aeronautics and Space Administration, and Adam Frank, an astrophysicist, formalized this problem. They published a paper titled The Silurian Hypothesis. They named it after a fictional species from Doctor Who, but the science is rigorous. They proposed that instead of looking for artifacts, we must look for consequences. An industrial civilization is a thermodynamic event. It extracts energy from the environment and dumps waste heat and chemicals back into the system. You cannot hide the thermodynamics. If a species burned massive amounts of carbon, they changed the atmosphere. If they used nuclear energy, they left isotopic scars. If they used agriculture on a global scale, they altered the nitrogen cycle. These are not physical objects. They are signals. And signals can be read even after the transmitter has turned to dust. The question changes from where are their cities to where is the signal in the noise. We have looked at the mechanism of erasure. Now in the next phase, we must examine the data itself. We must scan the timeline for the glitches that should not be there. Because if we look closely at the atomic record, we might find that someone else was burning the world long before we learned how to strike a match. We need to address the flaw in your search parameters. When you imagine a civilization, your brain immediately renders a specific set of images based on human history. You picture stone pillars like the Parthenon. You imagine carved idols like the Sphinx. You envision vast networks of paved roads like the Roman Empire. You are looking for Atlantis, a romanticized underwater version of a human city. This is the streetlight effect applied to archaeology. You are looking for the keys where the light is not where you drop them. You are looking for things that resemble you. But this projection is a cognitive error. It assumes that technology and intelligence must follow the specific path of stacking heavy rocks and smelting iron. It assumes that a pre-human intelligence would have the same aesthetic desires, the same religious impulses to build monuments, and the same logistical needs as a bipedal ape. This is an anthropocentric filter that blinds us to the data. Consider the interface theory of perception. We do not see reality. We see a simplified desktop icon that helps us survive. When we look at the geological strata, we are scanning for icons we recognize. Wall, tool, bone. If the object does not match the icon, our brain filters it out as background noise or natural formation. What if the civilization that came before us did not care about stone? What if their architecture was based on acoustics rather than mass? What if they lived in complex excavated tunnel systems that collapsed into indistinguishable geological layers? Or what if they were migratory, possessing high intelligence and complex oral traditions, but refusing to scar the land with permanent structures? We assume that advanced means heavy. We assume that civilized means modifying the landscape. But that is a primitive definition. A truly advanced species might understand the cost of entropy better than we do. They might have lived lightly, leaving no physical mark on the crust. By looking for the ruins of an Empire State Building, we might be missing the subtle, elegant traces of a species that was smart enough not to build one. We are staring at the static on the screen, waiting for a clear broadcast, not realizing that the static itself is the message. To find them, we have to stop looking for a reflection of ourselves. Let us deepen this paradox. There is a counterintuitive rule in the evolution of technology. The more advanced a civilization becomes, the less physical evidence it leaves behind. Look at the trajectory of human history. The Industrial Revolution was messy. We built massive, inefficient steam engines. We burned coal in open furnaces. We built thick, heavy brick factories. We left a lot of trash. A 19th century locomotive is a very obvious archaeological artifact. It is big, heavy, and made of iron. But look at today. We are moving toward miniaturization. We are moving toward the cloud. Our data is not carved in stone. It is stored in magnetic orientations on fragile drives. Our devices are getting smaller using less material. A smartphone contains more processing power than a room-sized computer from the 1950s, but it leaves a much smaller physical footprint. Now, extrapolate this trend. A civilization that survives for 1 million years cannot run on a take-make-waste linear economy. That is a suicide pact with the planet. They would run out of resources in a few centuries, just as we are doing now. To survive deep time, a civilization must achieve a closed-loop economy. They must recycle 100% of their material. They must leave zero waste. This is the urns paradox. You expect to find their garbage dumps, their nuclear waste, their plastic islands. But a successful civilization does not have garbage dumps. Their waste is their fuel. Their plastic is endlessly repolymerized. Their efficiency is their camouflage. If a society reached a level of perfect sustainability, they would be invisible to archaeology. They would not leave strip mines because they would mine their own landfills. They would not leave plastic in the ocean because they would capture every molecule. The only civilization we can easily detect is a failed civilization, one that crashed and burned, leaving a mess. A successful civilization looks exactly like a pristine natural ecosystem. They blend back into the background radiation of the planet. So the fact that we do not find massive landfills from the Jurassic period does not mean no one was there. It might just mean they were smarter than us. They did not soil their own nest. We have discussed the invisibility of efficiency. Now let us discuss the invisibility of the medium. We are obsessed with metallurgy. We divide our own history by metals. The Bronze Age, the Iron Age. We assume that technology requires the smelting of ore, but this is a sample size of one. What if the path to industry does not go through the blast furnace? What if it goes through the genome? Imagine a civilization that mastered biology instead of physics. Instead of mining silicon to build solar panels, they genetically engineered broadleaf plants to function as photovoltaic collectors with 90% efficiency. Instead of smelting steel beams to build houses, they manipulated the DNA of coral or fungi to grow calcified weatherproof structures that repair themselves. Instead of burning oil for transport, they bred massive beasts of burden or grew living vessels. This is soft technology, and it is the ultimate stealth technology in the geological record. A house grown from modified bone or cellulose is indistinguishable from a natural fossil once it dies. A computer based on neural tissue decays into protein soup. A vehicle made of muscle and chitin leaves no rust. If a species flourished for 5 million years using advanced biotechnology, their entire technosphere would be biodegradable. When they vanished, perhaps due to a plague or a genetic error, their cities would not crumble, they would rot. They would compost. Within 1,000 years, their machines would be indistinguishable from the topsoil. We might be walking through a forest that is actually the feral descendant of their data storage systems. We might be eating fruits that were engineered by their agricultural scientists millions of years ago. We are looking for gears and pistons in a world where the technology might have been wet, squishy, and alive. The absence of metal is not the absence of tools, it is simply the absence of the specific crude tools we happen to use. If we cannot trust shapes and we cannot trust materials, what can we trust? We can trust the atom. Specifically, we can trust the nucleus of the carbon atom. This is where we stop guessing and start measuring. To understand the Silurian signal, you need to understand isotopes. Most carbon atoms in the universe are carbon-12. They have 6 protons and 6 neutrons. They are light. But a small percentage of carbon is carbon-13. It has an extra neutron. It is heavier. Chemically, they behave the same, but physically the weight matters. Life is lazy. Biology prefers the lighter isotope. When a plant performs photosynthesis, it prefers to grab the lighter carbon-12 molecules from the air because it takes slightly less energy to process them. It discriminates against the heavy carbon-13. This means that every living thing, a tree, a dinosaur, you, a blade of grass, is enriched in carbon-12. We are light carbon. The inorganic world volcano's limestone rocks, the mantle has a standard mix of heavy and light carbon. This separation creates a signal. When a living thing dies and becomes fossilized fuel, coal oil gas, that fuel is a concentrated bomb of carbon-12. It is a massive reservoir of light carbon locked away underground. Now imagine what happens when an industrial civilization digs up that reservoir and burns it. They release gigatons of this light biological carbon back into the atmosphere all at once. It mixes with the air. It dissolves into the ocean. If you are a geologist examining rock layers formed during that period, you will see a sudden violent shift in the ratio. The amount of carbon-13 drops relative to carbon-12. The rock record registers a carbon isotope excursion. This is the atomic barcode of industry. It is not a subtle hint. It is a scream. It says, something pulled billions of tons of old life out of the ground and burned it. This signal cannot be eroded. It cannot be composted. It is locked in the chemical lattice of the planet forever. This phenomenon has a name. We call it the Suez effect, named after the scientist Hans Suess, who detected it in the mid-20th century. He noticed that the carbon in the modern atmosphere was getting lighter. The radioactive isotopes were being diluted by ancient dead carbon from fossil fuels. This is the fingerprint of the Anthropocene. We are currently injecting a massive spike of carbon-12 into the geological record. We are staining the timeline. Even if every building falls and every plastic bottle is eaten by bacteria, this chemical stain will remain. A geologist, 100 million years from now, could sample a piece of limestone from our era, put it in a mass spectrometer, and see the spike. They would know that something disrupted the carbon cycle violently and rapidly. So the protocol for finding the others is clear. We do not look for gold statues. We scan the timeline for the Suez effect. We scan for moments in deep history where the carbon ratio went haywire without a natural explanation. We look for the spike. Nature changes the carbon cycle slowly. Volcanoes can release carbon, but they do it over tens of thousands of years, and the isotopic mix is different mantle carbon is heavier. A sudden sharp injection of light carbon is suspicious. It suggests a biological origin, but released at an industrial speed. We have now defined our target. We are looking for a thermal and chemical shock in the rock record, a fever chart of the planet. And when we apply this filter to the data we already have, when we look back at the chaotic graphs of Earth's climate history, we do not see a flat line. We see pulses. We see anomalies. We see moments where the Earth screamed, "Let us move to the evidence room." Because 56 million years ago, the thermometer broke, and nobody knows exactly why. Carbon is the primary signal, but it is not the only one. If a civilization is large enough to be industrial, it must solve the problem of hunger. And to feed billions, you cannot rely on natural growth. You need to hack the nitrogen cycle. In our case, we invented the Haber-Bosch process in the early 20th century. We learned how to pull nitrogen out of the air and convert it into synthetic fertilizer. This was a miraculous expansion of the Earth's carrying capacity. Today, about half of the nitrogen atoms in your body came from a factory, not a natural soil process. But this hack has a cost. We dump millions of tons of nitrogen onto our fields. The crops cannot absorb it all. The rain washes the excess into rivers. The rivers carry it to the ocean. There, the nitrogen acts as a superfuel for algae. The algae bloom explosively die and rot. The rotting process consumes all the oxygen in the water. The result is a dead zone, an anoxic event, where nothing can breathe. We see these zones today at the mouths of the Mississippi, the Nile, the Yangtze. To a future geologist, these zones will appear as sudden layers of black, organic, rich shale, devoid of bottom-dwelling fossils. So our second detection filter is the nitrogen spike. We are looking for a sudden perturbation in the nitrogen-15 isotope record coinciding with coastal dead zones. If we find a moment in the deep past where the rivers suddenly dumped massive amounts of nutrients into the sea causing a localized extinction, we have to ask a question. Was that a natural flood? Or was it the runoff from a continental-scale farming empire that was desperate to feed its population? Before we start analyzing ancient anomalies, we must confront the greatest enemy of the deep time observer: the compression of the strata. We experience history day by day. To us, the Industrial Revolution was a long, complex saga of 300 years. The Roman Empire was a vast epoch of 1,000 years, but geology does not record days, it records eras. Sediment accumulates very slowly. In the deep ocean, it might take 1,000 years to accumulate a single centimeter of mud. On land, erosion might strip away layers entirely. The result is that the geological book has very thin pages. Imagine the entire history of human civilization, from the first Sumerian city to the launch of the James Webb Telescope, compressed into a layer of rock as thin as a fingernail. That is our reality. 6,000 years of drama invention and war equals a few millimeters of dirt. If a geologist drills a core sample, they might pull up a cylinder of rock representing 10 million years. In that cylinder, the entire existence of an industrial civilization like ours would be a single, microscopic band. A glitch in the data. If the sample is taken at a coarse resolution, say one measurement every 5 centimeters, the geologist would miss us entirely. We would fall between the data points. We might be looking right at them, but because our sampling resolution is too low, their entire history looks like a single bad day in the climate record. A momentary blip where the temperature jumped and then settled. We dismiss it as noise, but that noise could be the rise and fall of a species that loved and suffered just as much as we do. Furthermore, we are looking in the wrong places. We are victims of survivorship bias. We construct our history of the Earth based on the rocks we can access. We drill into continental shelves. We dig in deserts. We explore exposed cliff faces. But these represent a tiny fraction of the Earth's surface at any given time in the past. Most of the land surface from the Triassic, Jurassic, or Cretaceous periods has been destroyed by erosion or subduction. We are trying to reconstruct a movie from 3 random frames found on the cutting room floor. Consider where humans live. We cluster on coastlines and river deltas. These are high erosion or high deposition environments, but they are also the first places to be destroyed by sea level rise transgression or subduction. If an ancient species lived like us, building their megacities on the fertile edges of continents, their habitat is the least likely to be preserved. The fossils we do find are usually from unusual specific environments, stagnant lagoons, ash beds, tar pits. These are not where civilizations live. We do not build cities in tar pits. So the biological record is biased toward animals that lived in the middle of nowhere. We might have a perfect record of the ancient swamp creatures and 0 record of the ancient city builders, simply because the city builders lived on prime real estate that the Earth decided to recycle first. We are reading the history of the wilderness, not the history of the metropolis. There is one class of materials that defies both biological decay and isotopic ambiguity: the technosphere elements. Modern technology relies on elements that are rare in the Earth's crust, but concentrated in our devices. Rare Earth elements like lanthanum, neodymium, and gadolinium. Precious metals like gold, platinum, and rhodium. Industrial metals like chromium and vanadium. In a natural geological state, these elements are scattered. Entropy dictates that gold atoms are spread thinly through millions of tons of granite. But an industrial civilization functions as a localized entropy reversal machine. We expend massive amounts of energy to dig up millions of tons of rock crush, chemically separate the target atoms, and pile them up in our cities. We take the diffuse and make it dense. When a city like Tokyo or London eventually erodes, those concentrated metals do not simply vanish. They are washed downstream, but they remain chemically distinct. They create what geologists call a placer deposit, a sedimentary layer with unnaturally high concentrations of specific processed elements. Imagine a geologist drilling a core sample 50 million years from now. The rock is standard shale, standard limestone, and then suddenly there is a distinct band of clay where the concentration of gold, platinum, and neodymium spikes to 100 times the background level. More importantly, these metals will be found in alloy ratios that do not exist in nature. Nature creates gold nuggets. Nature does not create a fused alloy of aluminum, titanium, and chemically purified silicon. Finding these elements bonded together is a technosignature. It is a chemical fingerprint of manufacturing that persists long after the machine itself has rusted away. However, there is a massive complication in reading this signal. A natural model exists that can mimic this effect perfectly. Asteroids. Space rocks, specifically siderophile-rich meteorites, contain high concentrations of iridium, gold, and platinum. When a large asteroid strikes the Earth, it vaporizes and dusts the entire planet with a fine layer of these metals. So every time we find a metal spike in the deep past, we default to the asteroid hypothesis. We look at the iridium layer at the KPG boundary 66 million years ago, and we correctly attribute it to the Chicxulub impactor. The physics fits. But consider the blind spot this creates. This natural mechanism acts as a perfect mask. It provides a plausible geological cause for what might be an artificial deposit. If a civilization ended in a war that destroyed their infrastructure, or if their cities simply eroded over a million years, the resulting metal layer would look suspiciously like a small meteor impact or a series of volcanic eruptions. We attribute every metal anomaly to space or the mantle, utilizing the perfect default explanation for a dead civilization. We might be looking at the rusted remains of a planetary transport grid and calling it cosmic dust. We have now calibrated our sensors. We are no longer looking for Atlantis. We are looking for data. We have established a set of 4 primary detection filters for a lost industrial civilization. The carbon signal, a sharp, unexplained spike in carbon-12 or the Suez effect, indicating the rapid burning of organic fuel reservoirs. The nitrogen signal, a massive disruption in the global nitrogen cycle, indicating industrial-scale agriculture and fertilizer runoff. The technosphere signal, a sedimentary layer containing technometals or unusual alloy ratios. The thermal signal, a rapid global warming event caused by the greenhouse gases released by points 1 and 2. Essentially, we are looking for a planetary fever accompanied by a specific chemical cough. We are looking for a moment where the Earth system was pushed out of equilibrium faster than natural forces typically allow. Now, let us turn the telescope backward. Let us scan the timeline of Earth, not with the eyes of a paleontologist looking for bones, but with the eyes of a systems analyst looking for a perturbation. Most of Earth's climate history is gradual. Continental drift takes millions of years to alter ocean currents. Evolution takes millions of years to alter the biosphere. The graphs of deep time usually look like gentle rolling hills, slow rises and slow falls, but there are moments, violent jagged spikes where the graph goes vertical. Moments where the Earth suddenly caught fire. Moments where the ocean choked and died. Moments that look suspiciously like now. These hypothermals are the most violent events in the climate record, and the most famous, most well-documented of these events occurred roughly 56 million years ago. It is called the Paleocene-Eocene Thermal Maximum, or PETM. For decades, geologists have studied the PETM as a curiosity. But the more we refine our data, the more uncomfortable the comparison becomes. The chemistry of that event is not just similar to the Anthropocene model, it is a mathematical mirror image. The rate of carbon release, the magnitude of the warming, the response of the ocean, it all aligns. If we were looking for a candidate, a moment in time where the Earth might have hosted a high-energy civilization that burned itself out, we would not look at the time of the dinosaurs. We would look here. Let us open the dataset on the PETM and see why the numbers are keeping scientists awake at night. 56 million years ago, the Earth was already warm. There were no ice caps. Forests stretched to the poles. But then something snapped. In a geological instant, perhaps less than 5,000 years, maybe even faster, the global temperature rocketed upward by 5 to 8 degrees Celsius. This was not a slow warming trend. This was a thermal shock. The oceans acidified. The oxygen levels in the deep sea crashed, causing a mass extinction of benthic foraminifera, tiny sea creatures. The weather patterns went chaotic. But the temperature is just the symptom. The cause is what matters. When we analyze the isotopes from the PETM, we find a massive negative carbon isotope excursion. Remember the Suez effect, the signal of light biological carbon being dumped into the air. The PETM has it. The data says that thousands of gigatons of carbon were injected into the atmosphere almost overnight. This carbon was like carbon-12, meaning it came from organic sources. It was not volcanic. Volcanoes release heavy mantle carbon. This was old dead biology being burned or released. The parallel is striking. If you overlay the graph of the PETM carbon release with the projected graph of the Anthropocene humanity burning all fossil fuels, they do not just look alike. They are mathematically congruent. The rate of release, the isotopic signature, the resulting temperature spike is the same fingerprint. We are staring at an event that did exactly what we are doing with the same chemistry and the same result. The Earth caught a fever 56 million years ago, and the symptoms are identical to the industrial infection we are spreading today. Science demands skepticism. We cannot jump to aliens when a volcano will do. So geologists have proposed natural explanations for the PETM. The leading theory is the methane hydrate release. The theory goes like this. The Earth warmed slightly due to orbital wobbles. This warmth reached the ocean floor, destabilizing vast deposits of frozen methane hydrates. The methane bubbled up, entered the atmosphere, and since methane is a potent greenhouse gas, it caused rapid warming. This warming melted more hydrates, creating a feedback loop. It is a solid theory. It explains the light carbon because methane is biological in origin, but there are cracks in the explanation. First, the timing. Recent high-resolution studies suggest the carbon release was pulsatile, occurring in sharp bursts rather than a smooth feedback loop. Second, the source. We are not certain there were enough methane hydrates in the Paleocene oceans to account for the sheer magnitude of the spike. Third, the trigger. Why did it happen then? The Earth has been warm before. Why did the release happen specifically at 56 million years ago? And then, there is the uncomfortable question of speed. Some models suggest the carbon was released faster than natural feedbacks can explain. Nature is powerful, but it usually has inertia. The PETM looks less like a planetary cycle and more like a planetary accident, or an intentional extraction. The natural explanation is probable, but it is not proven. The door is left ajar, and through that crack, the Silurian hypothesis enters. Let us look at the world where this event happened. The Paleocene-Eocene boundary was not a desolate wasteland. It was a lush, thriving biosphere. Because of the high temperatures, there was no snow. Palm trees grew in Alaska. Crocodiles swam in the Arctic Ocean. The planet was a greenhouse paradise. The sea levels were high, creating vast, shallow inland seas, the perfect highways for trade if anyone was there to trade. If an intelligent species evolved in this era, they would not have to deal with harsh winters. They would not need heavy insulation. They could spread easily across the globe. It was a Goldilocks epoch for civilization. High biodiversity meant abundant resources. High temperatures meant easy agriculture. This timing is suspicious. We often think intelligence arises from adversity, the ice ages, forcing humans to get smart. But what if intelligence arises from abundance? What if the Eocene was the perfect petri dish for a high-energy civilization? And crucially, because the sea levels were so high, the land they would have lived on the Eocene coastlines is now deeply submerged or eroded away. The geography of the PETM hides its own secrets perfectly. The paradise burned, and the evidence of the inhabitants was washed into the deep ocean trenches. The PETM is the strongest candidate, but it is not the only one. If we scan further back into the Cretaceous, the time of the dinosaurs, we find other anomalies called oceanic anoxic events, or OAEs. OAE1 are 120 million years ago, and OAE 293 million years ago. These were periods when the oceans of the Earth suddenly lost oxygen. The deep sea became a dead zone. Black shale was deposited globally. Why? The standard answer is massive volcanic activity causing global warming and nutrient runoff. But nutrient runoff sounds familiar. It sounds like the nitrogen spike we discussed earlier. It sounds like industrial agriculture running wild, washing fertilizers into the sea, causing algae blooms that choke the water. During these OAEs, the carbon cycle went chaotic. The climate swung wildly. Species went extinct. And then, just as mysteriously, the system stabilized. The fever broke. Were these natural spasms of a volcanic planet? Almost certainly. But the pattern, carbon spike plus warming plus dead oceans, is exactly the pattern of an industrial collapse. We are looking at a repeated signal in the data. A pulse that happens every 50 or 100 million years. Is it a geological heartbeat? Or is it the rise and fall of civilizations hitting the resource limit? Let us go back even further. 360 million years ago. The late Devonian. This was long before dinosaurs. The land was colonized by the first forests. There was a mass extinction event here. But unlike the dinosaur killer, there is no giant crater. No single obvious trigger. Instead, the extinction was drawn out. It seems driven by anoxia, lack of oxygen in the oceans, and rapid climate cooling. One theory is that the evolution of trees caused it. Trees grew roots. Roots broke up rocks. This released massive amounts of nutrients into the ocean, acting as natural fertilizer. This caused algae blooms. The algae killed the oceans. Wait. A new biological species radically alters the environment, changes the nutrient cycle, and causes a mass extinction. That is the definition of the Devonian crisis, but it is also the definition of the Anthropocene. In the Devonian, the driver was trees. In the Anthropocene, the driver is us. The mechanism is the same. A species becomes too successful, disrupts the planetary chemistry, and triggers a collapse. Does it matter if the species was a mindless tree or a thinking ape? The signal in the rock is the same, but it opens a terrifying possibility. Maybe civilization is not special. Maybe it is just another form of invasive species event. We are just the trees of the Cenozoic breaking things because we are growing too fast. And like the trees, we might be triggering a reset that we cannot control. We have established the event site and the fingerprints, meaning the carbon spikes. Now let us talk about the candidates. Who could have built a civilization 60 or 100 million years ago? We must discard the sci-fi image of a human in a spacesuit. Evolution does not repeat itself, but intelligence. Intelligence is convergent. Eyes evolved independently 40 times. Wings evolved 4 times. Intelligence is just a tool for survival. If the environment demands it, nature builds a brain. Look at the troodontids. These were small bird-like dinosaurs from the late Cretaceous. They had large eyes, grasping hands with opposable thumbs, and crucially they had one of the highest encephalization quotients, brain-to-body mass ratio of any dinosaur. They were smart, pack hunters, communicators. If the asteroid had not hit, what would 10 million years of evolution have done to the Troodon brain? They were already on the path. They had the hardware manipulators and processors. Now imagine a Troodon civilization, not building stone castles, but weaving complex cities from forest materials, using fire, developing a language, maybe even rudimentary chemistry. If they stayed in the Stone Age or Wood Age, they would be utterly invisible. But if they stumbled upon coal, if they started burning the forest to clear land, they would trigger the carbon spike we see. They would not need to build iPhones to destroy the planet. They just needed to burn enough carbon. Intelligence does not need to be high-tech to be destructive. But why assume they lived on land? The ocean has existed far longer than the forests. And in the ocean, there is a distinct lineage of high intelligence. The cephalopods. Octopuses, squid, cuttlefish. Octopuses are alien intelligences on Earth. They solve puzzles, use tools, and have decentralized brains. 300 million years ago, giant cephalopods, ammonites, and orthocones ruled the seas. Could an underwater civilization exist? Physics makes it hard. You cannot light a fire underwater. Without fire, you cannot smelt metal. This is the energy barrier. It seems to trap aquatic species in a pre-industrial state. But is fire the only path to technology? We assume yes because we are fire creatures. But an advanced cephalopod society might have mastered chemistry using hydrothermal vents. They might have used biological engineering breeding coral into cities using electric eels for power, using pressure differences for work. Such a civilization would be silent to our senses. No radio waves water blocks them, no metal smog, but they would leave a chemical trace. If they farmed the ocean floor, they would disrupt the nitrogen and phosphorus cycles. If they had a global population, they would alter the food web. The strange anoxic events of the past might not be volcanic. They might be the result of a global aquatic empire collapsing the marine ecosystem. There is a third form of intelligence, the hive. Termites build air-conditioned cathedrals, ants farm fungus and wage war. Bees communicate via dance. Individual insects are dumb. The colony is a genius. This is distributed intelligence. Imagine a species of super termites evolving 200 million years ago. They build megastructures from soil and saliva, which turn back to dirt. They farm vast tracts of fungus underground, releasing methane. They strip mine the forest for cellulose. A global superhive would look like a geological force. It would consume carbon, release methane, and change the albedo of the planet. It would not have philosophy or art in a human sense. It would just be a relentless, expanding machine of consumption. The carbon spike of the thermal maximum massive methane release fits the profile of a biological super event perfectly. Maybe it was not a person who burned the world. Maybe it was a swarm. A civilization without a conscious self, just a blind, hungry algorithm made of meat, consuming the biosphere until it hit the limits of physics. There is one major counter-argument to all of this. One place where erosion is slow, one place that keeps secrets: the moon. If a civilization became advanced enough to leave the planet, they should have left debris on the moon. A flag, a rover, a base. The moon has no wind, no rain, no plate tectonics. Footprints from 1969 are still there. We have mapped the moon with high resolution via the Lunar Reconnaissance Orbiter. We have not seen any alien bases. This suggests that no prior Earth species became spacefaring. This is a strong filter. It implies that if they existed, they were Earthbound. But even the moon is not eternal. It is constantly bombarded by micrometeorites. Over millions of years, this gardening churns the top few meters of lunar soil, or regolith. A flag left 50 million years ago would be shredded by ultraviolet radiation and buried by dust. A metal rover would be pitted and unrecognizable. Unless they built massive stone monuments or underground bunkers, the moon might have erased them too. Or, and this is the darker thought, maybe they never made it to the moon. Maybe the Great Filter stops civilizations before they can leave their gravity well. The silence of the moon is not proof that they did not exist. It is proof that they did not escape. What about satellites? If we disappeared, our GPS satellites would orbit for a long time, but not forever. Low Earth orbit has atmospheric drag. The International Space Station has to boost itself constantly, or it falls. Within 10 to 20 years, most low satellites burn up. Geostationary satellites in high orbit are stable for millions of years, but orbits are chaotic over deep time. Solar radiation pressure, lunar gravity, and collisions with space debris destabilize them. And then there is the Kessler syndrome. If a civilization fights a war in orbit, they smash their satellites into billions of fragments. Over time, these fragments grind each other down into dust. Eventually everything falls, everything burns up in the atmosphere. A civilization that reached our level 50 million years ago would not leave a ring of satellites. They would leave a thin layer of vaporized aluminum and titanium in the upper atmosphere, which eventually settles as dust. We are back to the chemical signal. The sky is clean because the sky cleans itself. Gravity is the ultimate janitor. We often imagine the end of a civilization as a cinematic event. An asteroid impact, an alien invasion, a zombie plague. We look outward for the executioner. But the Silurian hypothesis forces us to look inward at the very laws that govern growth and energy. It suggests that the executioner is us. This brings us to the concept of the Great Filter, applied not to the stars, but to the Earth itself. The theory states that there is a barrier in the development of life that makes the transition to a long-lasting technological civilization statistically impossible. What if that barrier is thermodynamics? Consider the mechanism of complexity. A hunter-gatherer society is low complexity. It requires very little energy to maintain. A spear breaks, you make a new one. But an industrial society is a high complexity heat engine. To maintain a city like Tokyo or New York, you need a constant massive inflow of high-grade energy and a constant massive outflow of entropy, meaning waste, heat, and pollution. The second law of thermodynamics is not a suggestion, it is a debt. You cannot create order a city without creating greater disorder pollution elsewhere. The faster you build the city, the faster you generate the disorder. Here is the trap. The resources required to jumpstart a civilization, meaning fossil fuels and easy metals, are finite. They are the savings account of the planet accumulated over hundreds of millions of years. A civilization burns through this savings account in a few centuries. We have consumed more easily accessible energy in the last 100 years than in the previous 100,000 years combined. If a pre-human species hit this same wall 50 million years ago, they would have faced the same crisis. As their complexity increased, their energy return on investment would decrease. The easy coal is gone. The easy oil is gone. You have to dig deeper, which costs more energy. Eventually, the cost of maintaining the complexity exceeds the available energy. The system becomes fragile. Then a small shock occurs. A drought, a plague, a minor war. In a low complexity system, this is a bad Tuesday. In a high complexity system running on the edge of thermodynamic collapse, this triggers a cascade failure. The supply chains break, the power grids fail, the cities starve. The Great Filter might simply be the inevitable result of a species growing too fast for its thermodynamic budget. It is not a test of morality, it is a math problem. You cannot run an exponential system on a finite battery. If the previous tenants of Earth failed to solve this equation, they did not need an asteroid to kill them. They simply ran out of juice and cannibalized themselves. The silence of the past is the silence of an engine that stalled. This thermodynamic reality leads to the most terrifying implication of the Silurian hypothesis. The one-shot theory. Think about how we built our world. We walked into a forest and found coal sitting on the surface. We stuck a pipe in the ground in Texas and oil gushed out under its own pressure. We picked up nuggets of pure copper from riverbeds. Nature laid out a feast of easy energy for us. This easy energy allowed us to build the machines that could dig for the hard energy. It was a ladder. But what happens if you climb the ladder and then kick it away? If a previous civilization existed, they would have harvested the easy resources first. They would have mined the surface coal. They would have drained the shallow oil fields. If they then collapsed what is left for the next species. The next intelligent species, meaning us, would evolve on a planet that looks pristine, but is actually depleted. We would walk into the forest but find no surface coal. We would stick a pipe in the ground but find no pressure. We would be smart, we would have the potential, but we would lack the dense energy source needed to jumpstart the Industrial Revolution. We would be trapped in the Stone Age or the Agrarian Age, forever surrounded by the invisible ghosts of the resources that were stolen from us. But we did find coal, we did find oil. This observation, the fact that we found a full pantry, leads to two possibilities. Possibility A, we are truly the first. The pantry was full because no one had ever eaten from it. Possibility B, the pantry refills itself. And this is where the timeline gets dark. Fossil fuels are renewable if you wait long enough. It takes about 10 to 20 million years for the Earth to accumulate a significant new layer of peat and plankton and cook it into coal and oil. Now, look at the gaps in the geological record. The thermal maximum was 56 million years ago. The Cretaceous anoxic event was 90 million years ago. The gaps between these major carbon spikes are tens of millions of years. The timing is suspicious. It is almost exactly the time required for the Earth to recharge its battery. Are we part of a cycle? Does the Earth grow a civilization, let it burn all the fuel crash, it wait 20 million years for the fuel to regenerate and then grow a new one? We might not be the owners of the planet. We might just be the harvest of the current season. We are burning the corpses of the Cretaceous epoch to build our towers. Who will burn our corpses to build theirs in 50 million years? The Earth behaves like a slow, recharging capacitor. When the charge is full, intelligence evolves, discharges the energy in a violent flash of industry, what we call history, and then the system goes dark to recharge. We are not the masters of power. We are just the spark in the discharge. If energy is the fuel of the cycle, climate is the kill switch. We tend to view climate change as a problem to be solved, a technical glitch in our otherwise perfect domination of the planet. But the Silurian hypothesis suggests that climate instability is not a glitch. It is a fundamental feature of any industrial civilization, a built-in autoimmune response of the biosphere. You cannot do work without generating heat. This is basic physics. But more importantly, you cannot build a global infrastructure without manipulating matter. You turn forests into farms. You turn rocks into cement. You turn fossilized carbon into gas. Every single one of these actions releases greenhouse gases. Here is the climate sensitivity lock. It appears physically impossible to build a high-energy civilization without triggering a climate catastrophe. It is a race. Can you invent clean energy before the feedback loops kick in? Look at the thermal maximum again. The warming there was 5 to 8 degrees. That is the exact number our current climate models predict for business. As usual, carbon emissions. It is not a random number. It is the breaking point of the planetary thermostat. If a previous species tried to industrialize, they would have hit the same limit. As they burned their way to progress, they would have unlocked the methane hydrates, the methane gun. They would have melted the poles. They would have acidified the oceans. And here is the horror. The response of the planet is always disproportionate. You push the temperature up by 1 degree, and the planet responds by pushing it up by 5. Positive feedback loops albedo loss, permafrost, melt, forest fires take over. The civilization loses control. Their breadbaskets turn to deserts. Their coastal cities flood. Their economy collapses under the weight of disaster mitigation. They spend all their energy building seawalls instead of spaceships. This is the soft filter. It does not kill everyone. It just breaks the back of the civilization. It knocks them down from the industrial age to a scavenger age. They survive, but they are broken. They live in the ruins of a world they cook slowly, forgetting how to build the machines, until they are just another animal wandering through a jungle that grew over their greatest achievements. The climate record of Earth is full of these fever spikes. We call them hyperthermals. Maybe we should call them failed attempts. Each spike represents a species that reached for the stars, tripped the climate alarm, and was beaten back down by the heat. Let us move from the atmosphere to the blood. There is another way a civilization can leave a mark, one that survives longer than stone and is more precise than carbon. Genetic engineering. If a species mastered biology, they would inevitably weaponize it. War is a constant. And the most efficient weapon is not a nuclear bomb that destroys resources, it is a virus that destroys the enemy, while leaving the cities intact. We are currently seeing the rise of CRISPR and synthetic biology. It is only a matter of time before we can code viruses from scratch. Now, imagine a pre-Silurian Cold War. 2 rival factions of an ancient species. One unleashes a designed pathogen, a doomsday virus. It targets a specific genetic marker. It wipes out 99% of the population in a year. The civilization collapses instantly. Would we find traces of this war? Surprisingly, yes. But we have to look inside our own DNA. Our genome is full of junk DNA sequences that do not seem to code for anything. But a huge chunk of this junk is actually endogenous retroviruses. These are the fossilized remains of ancient viruses that infected our ancestors millions of years ago and got stuck in our genetic code. We carry the ghosts of ancient plagues in every cell of our bodies. Usually we assume these were natural plagues. But a synthetic virus might leave a signature, a sequence too orderly, too efficient to be natural. Geneticists are just beginning to decode this dark matter of the genome. What if the great dying events of the past were not asteroids but bioweapons that got out of control? What if the sudden evolutionary jumps we see in the fossil record, the Cambrian explosion, or the rise of mammals were not accidents, but the result of ancient genetic tampering? We might be the feral descendants of a bioweapon experiment. Or we might be the survivors of a species that tried to play God and accidentally sterilized their own world. The silence of the past might be the silence of a quarantine zone. If this is true, the evidence is not buried in the rock. It is walking around. We are the evidence. Our biology might be the scar tissue of a war we do not remember fighting. We talk about carbon and biology, but what about the ultimate signature? The split atom. If an industrial civilization advances far enough, it inevitably unlocks the strong nuclear force. It builds reactors. It builds bombs. Nuclear isotopes are the gold standard of deep time detection because nature does not produce certain isotopes in quantity. Plutonium, 244, curium, 247, iodine, 129. These have half-lives of millions of years. If a nuclear war happened 50 million years ago, would we know? The craters would be gone due to erosion. The cities would be gone due to subduction. But a thin layer of radioactive dust would settle globally. The problem is, after 50 million years, even plutonium-244 decays to almost nothing. It becomes a whisper in the background radiation. To detect it, you need to know exactly where to look, and have instruments sensitive enough to distinguish it from natural uranium decay. But we have found strange nuclear anomalies in the past. In 1972, French physicists discovered something impossible in a uranium mine in Oklo, Gabon. They found uranium ore that had already been burned. The ratio of uranium-235 was too low. It looked exactly like the spent fuel from a modern nuclear reactor. The scientific consensus is that this was a natural nuclear reactor. Groundwater seeped into a rich uranium vein, acted as a moderator, and started a fission chain reaction that ran for hundreds of thousands of years. Nature built a nuclear power plant by accident. It is a plausible theory, but it is also a very convenient one. It allows us to dismiss a clear nuclear signature as a freak, geological accident. The Silurian hypothesis asks us to be paranoid. Was Oklo really natural, or was it a waste dump? A buried storage facility for the spent fuel of a civilization that needed to hide its poison. And what about Mars? The Martian atmosphere has an excess of xenon-129. On Earth, xenon-129 is produced by nuclear weapons testing. Some physicists like Dr. John Brandenburg have argued this is evidence of a massive thermonuclear explosion on Mars in the distant past. Most scientists dismiss this as natural processes we do not yet understand. But the pattern repeats. Whenever we find a footprint, we call it a shadow. We explain away the impossible because the alternative that the atom was split before us is too terrifying to accept. Because if they split the atom and they are gone, it implies the atom eventually split them. Let us step back and look at the biological cost of all this. We assume intelligence is the goal of evolution. We think big brains are the winning strategy. But the fossil record tells a different story. Sharks have survived for 400 million years. Crocodiles for 200 million. They have small brains, low energy needs, and simple lifestyles. They are the winners. High intelligence, on the other hand, seems to be a lethal mutation. The human brain consumes 20% of the energy of the body, while occupying only 2% of its mass. It is metabolically expensive. To feed this brain, you need high-calorie food. To get high-calorie food, you need tools, fire, agriculture. To maintain agriculture, you need a stable climate. It is a fragile house of cards. The Silurian hypothesis suggests that high intelligence might be a self-limiting trait. It is an evolutionary experiment that nature tries, occasionally realizes it is a mistake, and then deletes. Maybe the Trudons got smart. They built a society. They overpopulated. They stripped their environment. They starved. And evolution said, okay, that did not work. Back to big teeth and small brains. Maybe the cycle we are seeing is not just about civilizations rising and falling. It is about the biosphere trying to sustain a planetary mind and failing every time because the mind consumes the body. We look at the stars and ask, where is everybody, meaning the Fermi paradox? The answer might be, they are all dead. Not because space is dangerous, but because thinking is dangerous. Intelligence is a flash fire. It burns bright, consumes all the oxygen in the room, and then suffocates itself. We are currently in the flash phase. We feel powerful, but we are burning the furniture to keep the fire going. And the history of Earth suggests that the house usually survives the fire, but the fire always goes out. We are not the pinnacle of evolution. We are its most dangerous gamble, and the odds are not in our favor. If you accept the possibility of one prior civilization, you have to accept the possibility of many. This is the floodgate logic. Once you admit that the geological record is gappy enough to hide the Industrial Revolution, you realize it is gappy enough to hide a chain of them. Imagine Earth history not as a line, but as a heartbeat. A pulse of intelligence, a fever of industry, a collapse, a long recovery. Repeat. This cyclical view changes our identity. We stop being the civilization and become civilization cycle number 5 or 10 or 50. We are seasonal. Just as the Earth has seasons of ice, glacials, and heat, interglacials, maybe it has seasons of mind. During the spring of the cycle, the planet is rich, oil has regenerated, metals have concentrated in veins, biodiversity is high, intelligence evolves to exploit this bounty. During the summer, the civilization booms, it builds cities, it burns the carbon, it reaches for the stars. During the autumn, the resources run dry. The climate destabilizes, the easy energy is gone. The civilization fights over the scraps and collapses. During the winter, the planet heals. The ruins erode. The carbon is slowly scrubbed from the atmosphere by rocks and oceans. The biosphere resets. And then, after 10 or 20 million years, spring returns. We are currently in late summer. We can feel the autumn wind blowing the resource scarcity, the climate instability. The terror of this theory is not just that we will die. It is that we are trapped in a loop. We are acting out a script that has been performed by lizards, by bugs, by cephalopods, by things we do not have names for. They all discovered fire. They all discovered the wheel. They all thought they were the first. And they all hit the wall. We are not special. We are just the current cast of actors in a tragedy that has been running for 500 million years. And the stage is covered in the dust of the previous performers. To truly feel the weight of this cycle, let us project ourselves forward. Let us jump 50 million years into the future. Humans are gone. The winter has passed. A new spring has arrived. A new species has evolved high intelligence. Let us say they evolved from rodents. Highly social, dexterous, curious rat people. They build universities, they invent geology, they start digging. What do they find of us? They do not find New York. New York is a layer of strange red sandstone rust in the cliff face of a new continent. They do not find the internet. The servers are dust. They find the layer. They find a razor-thin band of sedimentary rock that wraps around the globe. In this layer, they find a sudden spike in radioactive plutonium. They find a bizarre jump in carbon-12 isotopes. They find trace amounts of technofossils, plastic glomerates, rocks fused with plastic, and concentrations of rare earth metals that do not make geological sense. What is their theory? They will argue. One rat geologist will say, this layer represents a massive volcanic event that spewed carbon and rare metals. Another will say, no, it was a meteor impact that burned the forests. A fringe theorist will raise his hand and say, what if it was an ancient civilization? What if a species lived here 50 million years ago and did this? And the academic community will laugh at him. Impossible, they will say. If they were civilized, where are their cities? Where are their bones? We found dinosaur bones from 100 million years ago. Surely we would find the great apes. They will use the exact same arguments we use today to dismiss the Silurian hypothesis. They will look at our grave and call it a natural disaster. They will name our era the Anthropocene event, classifying us not as gods, but as a short-lived climate anomaly, a bad weekend in the history of the Earth. And then, having dismissed us, they will proceed to burn the newly regenerated oil, triggering their own collapse, unaware that they are walking on the warning signs we left behind. This scenario exposes the ultimate tragedy of the cycle, the lack of communication. We are trapped in a room with the ghosts of our predecessors, but we cannot hear them, and our successors will not hear us. The silence is not caused by a lack of intent, it is caused by the physics of the medium. We assume that information is eternal. We write books, we carve stone, we burn data onto optical discs. We believe that if we make the message clear enough, it will survive. But entropy is a noise generator that never sleeps. Paper lasts centuries. Microfilm lasts a millennium. Stone lasts 10,000 years. But we are trying to bridge a gap of millions of years. There is no material known to human engineering that can hold a coherent shape for 50 million years on an active planetary surface. Even nuclear waste markers, those giant stone spikes we plan to build to warn future generations about radiation, will be ground to dust by the next ice age. We are mute. If the civilization before us tried to warn us, how would they do it? Did they build a monolith? It is buried. Did they carve a mountain? It eroded. Did they leave a satellite? It burned up. Maybe the carbon spike of the thermal maximum was not an accident. Maybe it was not a war. Maybe it was a signal. What is the only thing that changes the entire planet globally instantly and leaves a trace for 100 million years? Climate change. Maybe they realize that stone fails and metal rots. Maybe they realized that the only way to leave a permanent mark was to scar the biosphere itself. Maybe they burned the world intentionally, not out of greed, but out of desperation to create a signal loud enough to say, "We were here to the future." If so, we are misinterpreting their desperate scream as a natural weather pattern. We are looking at a distress flare and calling it a sunrise. And now we face the same dilemma. If we know we are going to be erased, do we try to leave a message? Do we try to warn the rat people of the future about the oil trap, about the great filter? And if we do, how? How do you write a letter to a species that does not exist yet, in a language that has not been invented, written on a paper that will turn to magma? The answer is, you probably cannot. The cycle relies on the amnesia of the participants. The trap works because the new victim never sees the body of the old victim. But perhaps we are being too materialistic. We keep looking for external storage rocks and disks. But the most durable information storage system on Earth is internal. It is DNA. DNA has been copying itself successfully for 4 billion years. It is a digital code error, corrected self-replicating and designed to survive catastrophe. What if the library is not buried in the ground? What if it is walking around? In 2012, scientists at Harvard encoded a 53,000 word book into a strand of DNA. It occupied a volume smaller than a grain of sand. And as long as that DNA is inside a living, reproducing host, the data is preserved and copied for free. This leads to a staggering possibility. The non-coding DNA, often called junk DNA, makes up 98% of our genome. We do not know what most of it does. We assume it is evolutionary debris, broken virus parts, and stuttering repetitions. But what if it is an archive? Imagine a dying civilization 60 million years ago. They know the end is coming. Their cities will fall. Their monuments will crumble. So they launch a Noah's Ark project, not to save their bodies, but to save their knowledge. They synthetically encode their history, their mathematics, their warnings into the junk regions of the genome of a resilient, rapidly breeding mammal. A small mouse-like creature that will survive the collapse. That mammal evolves. It branches out. It becomes a lemur. It becomes a monkey. It becomes an ape. It becomes us. We might be carrying the Encyclopedia Galactica in our own blood. The warning about the Great Filter might be written in the repetitive sequences of our chromosome 19. But here is the cosmic irony. We are the storage device, but we do not have the password. We can sequence the genome, but we cannot read the context. We see the letters A, C, T, G, but we do not know the language. We are walking libraries, oblivious to the wisdom we carry, burning the same world that the authors of our DNA tried to save. This thought should terrify you. But let us flip the perspective. The Silurian hypothesis is scary because it destroys our ego. It tells us we are not the main character, but it also tells us something hopeful. Life is resilient. If we are not the first, that means the Earth is not a fragile miracle that happened once by accident. It means the Earth is a generator. It is a machine that produces intelligence again and again. Think about the dinosaurs. An asteroid hit them with the force of 1 billion nuclear bombs. It burned the atmosphere. It stopped photosynthesis for years. It was the apocalypse. And yet, here we are. The biosphere did not just survive, it bounced back. It evolved new forms. It produced mammals. It produced eyes that could read and hands that could build. If there was a civilization before us and they destroyed themselves, the fact that we are here proves that the planet recovered. It proves that the damage is not permanent. The fever breaks. The ice melts. The green returns. We are not living in a graveyard. We are living in a garden that is constantly replanting itself. This realization takes the pressure off. We do not have to be eternal to be valuable. A flower is not a failure because it dies in the winter. It succeeds because it bloomed in the summer. We are the summer bloom of the Cenozoic. Our job is not to be a statue made of stone that never changes. Our job is to be alive right now, to solve the puzzles we can solve, to experience the universe while the window is open. But accepting the cycle does not mean we should give up. If we accept the Silurian hypothesis, our ethical responsibility shifts dramatically. We used to think we were preserving the Earth for our children. That is a very small time frame. Now we have to think about preserving the Earth for the next ones. If we are the tenants of this geological era, we have a duty to the tenants who will move in after we are evicted. When we burn all the easy oil, we are stealing the starter pack from the next civilization. We are pulling up the ladder behind us. If we deplete all the rare earth metals and scatter them into the ocean, we are making it impossible for the intelligent rats or squids of the future to build a computer. We are condemning them to a permanent stone age. Maybe our purpose is not to live forever. Maybe our purpose is to be the first civilization in history to break the cycle of destruction, to be the first ones who do not eat all the food in the pantry. We are currently in the awkward adolescence of civilization. We are powerful enough to destroy the planet, but not wise enough to manage it. We are playing with matches in a library, but adolescence ends. We either grow up or we die young. The fact that we can even ask these questions, that we can see the thermal maximum that we can model, the climate that we can imagine deep time, suggests that we have a chance. The previous tenants might not have known what hit them. We do. We are the first species in the history of Earth that has the option to choose not to die. The cycle is a wheel, yes, but we have our hands on the rim. We can stop it, or at least we can steer. Let us go back to the start. The room you are sitting in, the screen, the feeling of now. In a universe of eternal recurrence, this moment has happened before. Somewhere in the deep past, a being sat in a room, looked at a screen or a scroll or a crystal, and wondered about the past. And somewhere in the deep future, a being will sit in a room and wonder about you. The loop is closed. The chain is unbroken. You are not isolated in time. You are surrounded by echoes. The anxiety you feel about the future, they felt it too. The awe you feel about the stars, they felt it too. The love you feel for your life, they felt it too. Nothing is ever truly lost because the pattern repeats. The details change: scales for skin, methane for oxygen stone for steel. But the experience of being alive, of being conscious, of being a world knower that is eternal, you are the universe experiencing itself in human form for a little while. And when the human form wears out, the universe will try again. It will try a new form, a better form. The story does not end when you close the book. The story is the paper. The story is the ink. The story is the reader. And the reader never dies. The reader just turns the page. Do not be afraid of the deep time. You are made of it. You are the current chapter of the greatest mystery story ever told. Sleep well.